You can use them all. We've drawn them for 2 days. So. Yeah, we should have several 10 by 10. So. All right, let's get started then. Let's talk about standard form. Particularly today, we're going to be looking at graphing with standard form. All right, give you time to write that down. All right, standard form equations have x and y on the same side. These a, b, and c are coefficients, and this is a constant. Standard form is usually recognized as having a, this number in front of x, has to be a positive whole number. So if we have fractions or decimals or a negative involved with a, we have to put that in standard form. So y'all be glad that we don't have any fractions involved. Alright, so let's take these 3 equations, which are right now not in standard form, and put them in standard form. So what would it take to get this over with the y? It's already negative, so we would add it to both sides. And so 2x plus y equals 3. That's just practicing putting an equation in standard form. This one's pretty easy. How would I get y over there with x? Add 13y. So x plus 13y is equal to 4. That's standard form. Not too bad. Yes, ma'am?
Does the x always have to come first?
That's a great question. Yes, it does. Okay. Make sure the x comes first. It's like alphabetical order, you know, what we typically do. Because when we start graphing it, if x is not first, then you got to fix it because you'll get everything wrong. That's a great question. All right, then we look at c here. 3/4 x minus 2 equals 3y. Well, a couple things wrong here. I have a fraction involved. Y is not over here with x. The constant's not over there by itself. So we got some work to do. What would the only common denominator be? There's only one denominator. I'm going to multiply everything by 4 to get rid of the fraction. And so the 4's cancel. So 3x minus 8 is equal to 12y. It's pretty easy to get rid of. Multiply everything by the common denominator. And then now I've got to bring y over here with x and take the 8 to the other side. So I would subtract 12y from both sides. And like you said, put it in order. So I've got x, and then I've got y. And now I've got to get the 8 to the other side also. And there it is. Whoops. There's standard form. So that's just, you know, looking at standard form, manipulating the formula around. Remember, you can't solve an equation that's got 2 variables for an answer. That's why we're going to do systems of equations later, because to solve an equation with 2 variables, you need 2 equations. You guys remember graphing, substitution, and elimination methods? A little bit? No? Okay. Alright, would you try those 3? Put them in standard form. It is.
Do we get to make up our work on this English stuff then? Or do we come president and just cancel school? After basic grade, no more employment.
About to hear another sound down here. Alright. Now what's wrong with the negative right here? It needs to be positive, doesn't it? So to change that, we'll multiply by -1. Now other things can be negative, as you see here, but just not the leading coefficient. What does that mean? Well, leading means there's a leader, right? first. And then coefficient's number in front of the variable. So the leading coefficient, the number in front of x, needs to be positive.
Now, does it matter if we just subtract 2y instead?
It does not. Subtract 2y, and that would have been even easier. 3x. See, that's true, because if I'd subtracted 2y, and I was afraid to get everybody confused if I did that, but if I'd have subtracted 2y, do you guys remember the symmetric property that says that I can just turn the whole equation around, see? So that works too. Alright, when we're looking at our, that's good thinking. When I'm looking at this equation here, first of all, I see decimals, and I see that they're all tenths with a th, and so I'm going to multiply everything here by 10 and move that decimal over. Well, and so that gets rid of that problem. And then I'm going to subtract my 43y from both sides. So 57x minus 43y minus 53 is equal to 0. Add 53 from both sides. Now I know those are giant numbers, but it holds all the rules. It's got a positive number here. There's no fractions or decimals, so I'd hate to have to graph that thing. Be taping graph paper together, and that'd be terrible. Spreading it out on the floor. Alright, here's what we want to remember. Here's the key part to graphing in standard form. We need to know these three little formulas right here. So I'll let you write those down for me real quick. Write down this example right here.
Did you have to cover that?
Alright, this is A, this is B, and this is C. When I learn something new, if this is new to you, I like to have something I can just go back and look at and say, okay, those were easy numbers. I see where all of that came from. I'm going to use that example as the one I go by. And so if this is A and B and C, and the slope is negative A over B, then negative 2 over negative 3 becomes positive 2/3. And if the x-intercept is C over A, and here is C and here is A, 6 over 2 is 3. And if the y-intercept is C over B, and here is C and here is B, 6 over negative 3 is negative 2. So I can even write that. This was 6 over 2. This was 6 over negative 3. Now, you have to remember this. Crucial. Critical. Gotta do that. If you forget these two, remember, if you're looking for the x-intercept in any problem, plug in 0 for y. If you're looking for the y-intercept in any problem, don't care what form it is, plug in 0 for the x. Whatever intercept you're looking for, plug in 0 for the other one. But this sure does make it easy, if you can remember those, to do them very quickly in your head. Now this is one case where you guys that like to not show your work and do it in your head, get to do it in your head, okay? Here's the formulas, just remember them. But now this is really important to remember. Now these only go with standard form, not slope-intercept form. Remember, with slope-intercept, to find the slope, we just looked in front of x, right? That's not what happens with standard form. The slope of this line is not 2. It's negative A over B. Alright, so we can just graph those. The slope was negative 2 over negative 3, which was positive 2/3. The x-intercept was 6 over 2. The y-intercept was 6 over negative 3. And so it just graphs the same. It's no difference in the graphing. You're still going to, rise over run. Connect the points. That's it. Okay? It's increasing left to right. It's got a positive slope. So that part of it's no different. But finding the information, negative A over B, C over A, C over B, that is different.